This is an energy problem that we are going to use an LOL chart and conservation of energy to solve. The question is about a very hefty cat, Patrick, who is pole vaulting over a bar. It gives us the information that he is running originally at a speed of 10 meters per second, and then when he crosses over the bar, he's moving at 1.7 meters per second. The problem says to neglect air resistance as well as any energy absorbed by the pole, and to determine his altitude as he crosses the bar. So first we'll start with our LOL chart. Remember, for our LOL charts, we begin by drawing an axis for the time period before the motion. We identify what our system is inside of our circle, and then we create a second chart for the second phase of the motion. In this first phase of motion, Patrick has some total mechanical energy that might look something like this. They tell us that he's in motion, and therefore we know he has kinetic energy. He's also on the ground, so all of his total mechanical energy at this point is kinetic energy. Again, he's on the ground, so our potential energy is simply at 0. Our system is Patrick. And so for our second phase of motion, Patrick is now crossing over the bar. So he has some height, and we know that he's still moving with a speed of 1.7 meters per second, which suggests he also has kinetic energy. So we begin with our total mechanical energy, which will remain the same as before because no work was done in or out of our system. Again, kinetic energy is going to be a little bit smaller this time because he's not moving as fast, which means that the rest of it needs to be made up of potential energy. Using conservation of energy, we're going to write an equation. In the beginning, the only type of energy he has is kinetic energy. And after his motion, he has kinetic energy and potential energy. Ultimately, we're looking for the height that he jumps. And that's going to come in the form of our potential energy. So let's expand on these equations so that we can do some calculations. The equation for kinetic energy is 1/2 mv squared. And it'll be similar over here, 1/2 mv squared, plus this new potential energy found by mgh. Again, h is what we're looking for. If we fill in some numbers, we know that this very large cat has a mass of 50 kilograms and is traveling at a speed of 10 meters per second during the first part of his motion. And then in the second part of his motion, again, he still has a mass of 50 kilograms, but he's only traveling at a velocity of 1.7 meters per second. To this, I'm going to add the mass of Patrick, which again is 50, times gravity, which is 9.8, times his height. Again, what we're looking for. To simplify this equation, or you may come across a problem where mass is not provided, we can see that the 50 kilograms is in each term of this equation, so I can actually just cancel it out. And then I can complete some calculations. When I simplify this equation, I find that the height that Patrick reaches during his jump is 4.95 meters. And that's our final answer.